Alright, so today we're going to be talking about composition of transformations. So the cool thing about transformations is if you pair any two together, you could actually do that same transformation in one transformation. You can do that same composition of transformations in a single transformation, with the exception of one. So our goal is to find out what that one is today, and then to practice doing all of them. Now, isometries we've already talked about. We just didn't call it an isometry. An isometry is going to be a rigid transformation. In other words, it preserves congruence. If it's that length, it's going to stay that length. If it's at that angle, it's going to stay at that angle. So translations, reflections, and rotations are all considered isometries. There are only 4 types of isometries. There are translations, which we've already talked about, rotations, which we've already talked about, and reflections. So here, the last isometry is found by doing 2 of the above in a row. So we're going to see which one we do that doesn't become one that we already know. So here, if we do 2 translations in a row, so we take 1 to 2 to 3, how could we have gone from 1 to 3 in a single move? Well, we could just do a translation. So another translation, which would just take x comma y straight to our x value went from -1 to 7. So it went right 8. And then it went down 2. So we could have done a single translation of that. So looking here, we have 2 different rotations, but they're going to be around the same center point. So we've got this center point, we've got P, we're going to rotate 135, we're going to rotate 90 degrees, and then we're going to rotate 45 more degrees. How could we have done that in one move? You're right, we could have just done a rotation of 135 degrees about P, C, our center, right? Alright, looking here, if we do 2 reflections over parallel lines, so there's 2 kinds of reflections that we could do. We could over parallel or over ones that are crossed. If we do 2 reflections over parallel, if you notice, A goes to A, B goes to B, C goes to C, this is just a translation. Now we don't know the exact amount because we're not given coordinate pairs, but we know it's translation. So here, what if we go around intersections using intersecting lines? Well, if you look at this, A goes to A, our C goes to C, and our B goes to B. How very odd. This looks very similar to a rotation. And in this case, it's a rotation of 180 degrees because we did 2 90 degrees, but it doesn't always have to be that much. It could be different. So what if we do a rotation and a reflection? So let's see. We rotate 90 degrees, and then we're going to flip it over to this one. So if we look at this, it's not just a translation because we can't move A to A and B is the same amount. It's not quite, or is it a reflection? It's not quite a rotation because then C would end up on top. But this looks to be a reflection over the line y equals -x. So this is just, so if we do a rotation followed by a reflection, we just end up with a reflection. In this case, we ended up with a reflection of or over y equals -x. Alright, so let's look at this one. So that wasn't new, we already knew that one. So we're going to do a translation followed by a rotation. So we're going to shift, and then we're going to rotate. So if I look at this, I can actually see that B is going to B, C is going to C, A is going to A. They all seem to be a rotation, but it's no longer using 0, 0 as my center. So this is a rotation. And let's figure out where that center of rotation is. So if we look at A to A, we know that this rotation amount of degrees has to be the same as C to C. So let's see, could it be here? Because it has to be the same distance from A as it is from A prime. It's too close to A prime. Could it be here? Let's see, that's 2 and 1 away. This is 2 and 1 away. Ooh. So this is a rotation 90 degrees counterclockwise. Instead of being about 0, 0, this one's about 2, negative 1. Interesting. All right. Well, what about this one? Let's see. If we slide or translate and then reflect, can we fold over any line and get this to land on top of here? Let's see. So R would have to be on this side. That's not going to work. Okay, so it's not a reflection. So reflection is out. It's not a translation because it's not just a shift. So it's not a translation. What about rotation? Let's see. That might be promising. So if we rotate this way, that would put R on that side where P is. It's not a rotation. So we've gone through all three of the ones we know. So this must be the new one. This is called a glide reflection. That's kind of cool. No, you're not tested on that. But those are all the different things that can happen if we do a composition. So now let's practice doing compositions in order. So first, we're given our triangle. Fabulous. Let's go ahead and label our points A, B, and C. So A is going to be 1, 6. B is going to be 5, 3. And C is going to be 4, 1. So the first thing we want to do is we want to translate with the rule x plus 4 and y plus 1. So x plus 4 means right 4, and y plus 1 means up 1. So let's take our A. We're going to go 1, 2, 3, 4, up 1. So our new A prime is going to be, oh, that wasn't right. I went left. 1, 2, 3, 4, up 1. So that's going to be at 5, 7. So here's A prime. We should probably change our color. A prime. All right, same thing for B. We're going to go 1, 2, 3, 4, up 1. Here's our B prime. And C, we're going to go 1, 2, 3, 4, up 1. Here's our C prime. So there is our beautiful first translation, or first transformation triangle. So our B prime is at 9, 4. And our C prime is at 8, 2. Perfect. All right, so then for the next one, we're going to reflect across the y-axis. So I'm going to mark my y-axis with a highlighter. If I reflect over this y-axis, A prime is starting 5 away. So now I want to go 5 away this way. So here's A double prime. So A double prime is negative 5, 7. B is starting at 9 away. So I want to stay at the height of 4. But I want to go 9 away the other direction. So that'll be negative 9, 4. Here's our B double prime. And C is 8 away from the blue line, so we're going to go 8 away the other direction. Here's our C double prime. So that'll be -8, 2. All right, so you guys are going to do one just like this with a different set of rules. You're going to start with a reflection, then do a translation, then do a rotation. You guys have got this. You'll end up with 4 different triangles. So this will be your A, B, and C. You're going to do the first reflection to get a new triangle. Then from that triangle, you're going to get your translation. From that triangle, you're going to get your rotation. Best of luck, guys.